Oops, I'm sorry. I thought I'm Naruto. That's my expectation. Like this one, like I'm Naruto. I run so cool and so fast. But in reality, I look like that. I look funny. I look silly, right? Because your expectation is different from reality. Just like probability, guys. There's a theoretical probability, but sometimes it's different from the experimental probability. And that's the lesson for today. Are you ready? Here we go. All right, so first let's define and see the difference. Theoretical probability, from the word theory, okay, it's ideal, it's the expected. It is what is expected to happen based on the possible outcomes, assuming equally likely events. In a perfect world, that's what you expect. Like Naruto over here, a perfect way to run. Like the probability of getting 4 if you throw a die. So how many fours are there in this one? You can only get 1 4 out of 6 possible outcomes. So 1 over 6. So you can say less likely. Okay, that's a theoretical probability. Now, let's go to experimental probability. It is the result of an experiment. You will actually throw the dice several times, okay? Or simulation after a large number of times. Not just once. Maybe, here in the experiment, we did it 6 times. We got 6, 6, 1, 3, 5, and 2, right? Now, when those are the results, did 4 actually come up? No, 4 wasn't there. And the actual results was 0 out of 6. Okay? We were expecting 1 out of 6, but in real life, what did we get? 0 out of 6. There's no guarantee that your theoretical will happen in real life. Okay? Bottom line, it's like that. The theory may be different from the experimental. Okay? But guess what? The theoretical could be our guide. Guide to predict, though. Predict. Because we already have an idea, it's going to be less likely. All right? So you're not going to bet all your money because the probability is 1 out of 6. Now, for example, the probability of getting ahead when you toss the coin is 1/2. We all know that. That's theoretical. But when you threw it 20 times, you were expecting what is half of 20? Okay, you were expecting 1 over 2. So if we throw it 20 times, we are expecting 10. All right, we are expecting 10. Will it actually be 10? But no. Let's see how many are the heads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 20. See? Are they the same? Okay. Are they the same? No, they're different, right? We were expecting at least 10, but we went over. Okay, theoretical versus experiment. One more. The probability of getting an even number. How many even numbers do I see here? 2, 4, 6, 8. So 4 out of 8. So we're expecting 1/2 again. But guess what? I spun the spinner 16 times. And I want to see a result of an even number. Let's circle the even numbers. 1, 2, 3, 4. 5, 6, 7. All right. So 1/2, when we threw it how many? 16 times. What is half of 16? 8. We were expecting 8. Okay. But in real life, how many did we get? 7 out of 16. Okay. Are they near each other? Almost. Okay. But they are different from each other. Okay. So now you see the difference. Today we're going to use the experimental probability in order to predict. Let's read the problem. Brandon took a survey of 48 out of the 200 students in the 7th grade to see if they were going on a summer vacation. 30 of the students said, yes, we're going on a summer vacation. Now, what is the good prediction of the number of 7th grade students who are going on a summer vacation? Okay, so you made an experiment. An experiment is like a survey, right? And the probability of those who said Yes, we're going to a summer vacation. Okay? Out of 48, 30 said yes. Do we all agree? That's your experimental. We're doing experimental right now. So guess what? I could still divide it by what? Divided by 6, divided by 6. Okay, the lowest terms will be what? 30 divided by 6 is a 5. 48 divided by 6 is an 8. Okay, we got it? 5 eighths. That's the experimental. Guess what? From the experimental, we can now predict. Since 5 out of 8 would say yes, what if there are 200 students? Remember our lesson before? Sample and population. So 5 out of 8 said yes. We will now equate it to what? 200. Where do I put 200? 200 goes below, okay? And the top will be x. Remember that? Okay. How many of what number, okay, times 8? 8 times what number gives me 200? You can use your calculator or mentally remember 100. There are 4 25s. So if it's 200, there are be what? Times 25. Okay, 8 25s. So times 25 below. What do I do below? I still do on top. Times 25. 5 times 25 is 125. All right. If you ask the whole seventh graders, what can you say? About 125 will say yes. They're going to have a summer vacation. Okay, so now let's try another example. Javier asked a random sample of 50 classmates whether they are interested in extending the school year. The results are shown in the table. There are 250 students in Doug's school. Based on this sample, how many students are in favor of extending the school year? So this is an experiment. A survey is the experiment. It's not theoretical yet because theoretical is set on stone. Okay, it's not always the same. Now, let's look at this. So, those who said yes is this one. 12 out of a total of what? They gave us a total already, and it matches 50. So, the probability, this is an experiment, just the experiment or the survey of those who will say yes, we are in favor is what? 12 out of 50. Okay, we're good with that? But I can simplify that. Divided by 2, divided by 2, the result will be what? 6 over 25. So that's less likely, right? It's not even half, it's lower than half. So guys, we were able to use an experiment. We will now use this to predict. Again, you could use your ratio chart or just write two fractions. 6 out of 25 is equal to what? I am now predicting from the whole school. 250. Where do I put 250? On top or below? Say it. Yes, it's below, not on top. The whole is always below. Okay, so the X would be there. And what pattern do I see? Everybody look. Oh, times 10 below. What will I do on top? Yes, times 10 also. So 6 times 10 is what? 60. There you go. So conclusion now. About, write the word about, 60 will be in favor of extending. See that? It's not perfect, but it will be about 60. And if you do the actual thing, you might get 59 or 62 or 61 as long as it's near 60. Okay, got it? Good. Let's now move on to the next problem. Now, you can also predict from your theoretical. Okay, a spinner is spun 80 times. What is the probability that will land on a prime number? Ooh, probability of a prime number. First, we have to identify which are the prime numbers. 1 is not a prime number. 2 is a prime number. 3 is a prime number, not 4. 5 is a prime number, not 6. 7 is a prime number, not 8. Okay, so again, 1, 1. Let's count the prime numbers 1, 2, 3, and 4. Therefore, I would write there would be 4 out of 8. Oh, you know what? Simplify it. Lowest terms is 1 half. Ooh, 50-50 chance. Okay, that's my theoretical. Theoretical. I can use that to predict. Predict. Okay, so probability of getting a prime is 1 out of 2. But how many times will I throw it? Yes, 80 times. 80 goes down. And what pattern do you see? What pattern do you see? Times 40. Therefore, on top, I will also do times 40. So the answer is 40. If I spin it 80 times, I'm expecting, it may or may not happen. It may or may not happen. It will be near how many? 40 times it will land on prime. Okay? I'm expecting that, but it may not happen. 40 times it will land on a prime. So remember, the more trials are conducted, the experimental probability generally gets closer to the theoretical. Now, remember, if you throw a dice, the probability of getting an even number is, what are the even numbers? 2, 4, 6, right? So if you throw it once, it's 1 half. That is in theory. But guess what? You threw it 10 times, you only got 3. That's not 1 half. Okay, it's away from 1 half. And you threw it 60 times, you got 49 out of 60. That's not 1 half. It's beyond the half, right? It doesn't match this. How come? Because it's just an experiment. But if I threw it 100 times, look at the result, 58. Is 58 near 50 over 100? Kinda, right? Almost 1 half. Now, if I threw it 2,000 times, look at the results. Is it near half, which is 1,000 over 2,000? Yes, it's getting nearer. It's not perfect, but it's getting nearer. But guess what? I threw it 10,000 times. The results is, okay, 5,001 out of 10,000. Is it near the half of 5,000? Yes, it got nearer. It got closer. Okay, so to make it closer, what will I do? Throw it more number of times. Okay, the more times you throw it, the closer it is to your theoretical. More experiments, right? More samples you have, okay, remember, the more it reflects the population. A standard deck of cards, which is 52 cards, contains suits like clubs, spades, hearts, and diamonds. Each deck contains an equal number of cards in each suit. Rochelle chooses a card from the deck, get a card, okay, records it. What's the result? And then replace it back. Okay, the results are shown below. Okay, so these are the results. How does the experimental probability of choosing a heart compare with the theoretical probability of choosing a heart? Okay, let's start with the, okay, since this is the experiment, okay, these are the experimental probability of getting a heart. Okay, so the probability of getting a heart, you could see it here, in the experiment is 15 out of a total of, let's add it up, 29 plus 13 plus 15 plus 23 is 80. Okay, 15 out of 80. Okay, there's the lowest terms for that. Divided by 15 divided by 5 is a 3. 80 divided by 5 is 16. Okay, that's the lowest terms. Are we good? That's the experimental. Now let's look at the theoretical. Remember, the theoretical is different. The probability of getting a heart in an ideal card, remember there are 52 cards. The A, the 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the Jack, Queen, King, there are 13 hearts. Okay, so guess what? You can simplify that as 1/4. Okay, but we want to know the difference between the two. Instead of writing 1/4, okay, I could rename this as, to make it the same denominator, 16. So what did I do? Times 4, and then you are also times 4 for 16. Okay? So now, I want to know the difference between these two. Okay? 4 over 16 minus 3 over 16 gives me 1/16. Oh, the difference. The theoretical is greater than the experimental. Okay, let's look at this. The theoretical probability of choosing the heart is 1/16 greater than the experimental. Perfect. Now, the experimental probability of choosing the heart is 1/6 greater. Is the experimental greater? No, 4/16 is greater than 3/16. So not you. Okay, is 126? No, it's not 126. No, it's not 126. So that's our correct answer. Got it? Good. Next, Walter. Walter is conducting an experiment using a spinner with 4 equal sections. Which number of trials will lead to experimental outcomes that are most similar to his predicted outcomes? Okay, so there is a spinner with 4 equal parts. Okay, and then he spun that spinner. Okay, which number of trials? How many times will he spin it? Number of times to spin, so that the experiment outcomes will be similar to his predicted outcomes. Okay, is it the more or the less? Remember the lesson? Yes, the more trials you do, the nearer it will be to the theoretical. Next, let's read this. Josiah conducts an experiment that has four possible outcomes. Sally conducts an experiment that has 10 possible outcomes. The students conduct 50 trials each. Which statement best compares the two experiments? Okay, let's start with Josiah and Sally. Sally has 4 possible outcomes. Okay, let's make it 4 then. All right. And then Sally got 10. Okay, 1, 2, 3, 4, 5. Okay, 4 possible outcomes, 10 possible outcomes. Okay, and then the students conduct 50 trials. Throw it 50 times, 50 times, 50 times. Okay, which statement best compares the two experiments? Josiah's results are more likely to be close to the predicted outcomes because he had a smaller number of possible outcomes. Okay, if you spin that, which would have more chances of landing on one? The bigger space, right? The bigger space will have more chances than this little space. Okay, that makes sense. It's fair because they're thrown 50 times. It's the same number of times. This makes sense. Sally's results, let's see the second one. Sally's results are more likely to be close to the predicted because she had a larger. No, Sally's not larger. It is smaller. Next, Josiah and Sally have the same. No, they're not the same. This is bigger than one area over here. Okay. Josiah and Sally had the same likelihood of experiments being close to the predicted results because the outcome of either experiment is unrelated to the outcome of the other experiment. No, they are related because they are thrown 50 times, okay, at the same number of times, 50 times. So our correct answer, makes sense, would be the first one. Okay, last problem. A set of cards contains the numbers 1 through 20. Matthew chooses a card at random, records the number of cards, then returns the card to the set. He conducts it 200 trials. Based on the theoretical probability, how many times can Matthew expect to choose a multiple of 5? Whoa. So let's write down all those cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not only 10, but 20. Okay? See, if you're a visual learner, I can actually draw. There's nothing wrong to draw the cards. Okay? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If that helps you, do that. Okay, now they're piled up together and you choose one. Okay, then you return it. Choose one again, then return it. Okay, now what is the probability after 200 trial? 200 times is going to get it. Okay, we want to get the multiples of 5. What are they? 5, 10, 15, and 20. Okay, so let's write it down. The probability of getting a 5, how many multiples of 5 did we get? The red ones? Yes, 4 out of a total of 20. Okay, so you can even simplify that. What's the lowest terms? Or divide by 2, divide by 2, that's 2 tenths. Divide by 2 again, divide by 2 again. You could say 1/5. Is that a good probability? It's near zero, so less likely it's going to happen. But guess what? That's the theoretical. We now do an experiment based on 200. Based on 200. So the the probability is 1/5. We will now predict the 200. See that? Okay, what pattern do you see from the bottom? Times 40. Okay, so on top I do times 40. Therefore, 1 times 40 is a 40. So what can you say? 40 times. Out of 200 trials, 40 of those will be a multiple of 5. But it's not a guarantee, but it's near 40. You could get 39 or 40, 43 or 41 as long as it's near 40. Okay? So that's it. So remember, guys, results is equal to action plus motivation. Good luck.